Welcome back. I hope that you had a fun time working on factoring those polynomials. I have the solutions here for you. Let me go ahead and put these here. Okay. I think so. This one. This one. This one was the same as the one we did above, so don't worry about that. This one. This one here. This one we didn't do any work with the two variables, so don't worry about that. This one. This one. This part right here in the middle is prime. There's no factors of 140 that add up to 28, so go ahead and leave that one. And finally, this one here. Okay? Alrighty, now, you might be wondering, why are we doing all this factoring? What is the point? It takes a long time. What's the purpose? Okay? This is where we're going to talk about zero product property. The factoring helps us to identify the pieces of the polynomial. Okay? So, meaning when we have a quadratic, goes like this. There's two pieces there, right? Goes down, decreases on one side, increases on the other side. Okay, so we have two pieces there. When those two parts are multiplied together, it gives us that quadratic polynomial. Okay, now another part of that, the zero product property, is related to all this. Okay, page 116, we see the beginning of zero product property. So what it says is that if a and b are real numbers, well, it says a and b are real numbers. So if a times b equals 0, then either a equals 0 or b equals 0. If the product of two numbers is 0, at least one of those numbers must be 0, which makes sense. If I'm multiplying a times b and I get a product of 0, then one of these has to equal 0, right? Yeah, it makes sense. Okay, so let's think about what this means for our quadratics, right? We have solved these to say, in this case, x plus 5x minus 6 equals 0. Okay? If you remember what we know about input-output, if we put a value in for x, it equals y, right? So in this case, we're saying that y is 0, right? Whatever we did over here, y is equal to 0. Okay, now what does that mean? If you think about the coordinate plane, that's a terrible x and y axis, but we're gonna go with it. Okay, so here we have x and y. If y equals 0, here's my y-axis. If y equals 0, where are we? That's right, we're somewhere on the x-axis, okay? So if y is equal to 0, we could be here, we could be here, we could be here, okay? We need to find out where we are. Does that make sense? We want to find out where we are on this x-axis, which is where our factors come into play. Okay, I said that when I multiply these, that y equals 0. Okay, so that means that if I take this one, x plus 5, and say that equals 0, and then I take x minus 6, and I say that equals 0, well, now I can solve for x. Okay, so here I subtract 5, x equals negative 5, add 6, x equals 6. Okay, so what this means is when my y is 0, x is 1, 2, 3, 4, negative 5, and 1, 2, 3, 4, 5, positive 6. Okay, so x equals negative 5 and x equals 6. So what do we have here? If we think about this, this gives us our intercepts. Okay, now I'm just going to sketch right now. I know that's positive, so we're going to open up. We have a quadratic that looks something like this. Okay, it opens up. We have an intercept at -5 and at 6. Okay, so x equals -5, 6. Okay, if I write these as intercepts, I have my intercept -5, 0, and 6, 0. Okay, so when we're using zero product property, we're saying that this equals 0, and when y is 0, x has a value that is somewhere on the x-axis. Okay, so what that means is that when we're factoring, we're finding our intercepts. Okay, we're finding the intercepts of the quadratic equation or the polynomial that we're working with. It all starts with factoring. So here we have x minus 10 times x plus 4. This one's already been factored. These are set equal to 0. So now if I want to know what my intercepts are, I set both of these equal to 0, and I solve for x. X equals 10. X equals -4. So I can say x equals 10, -4 if I'm asking you just to solve. If I'm asking you for the intercepts, however, you need to tell me that the intercepts are 10, 0, and -4, 0. Okay, so it depends on what I'm asking. If I'm just asking you to solve using zero product property, this is all we have to do. If I'm asking you to give me the intercepts, these are my intercepts right here. Okay, this is the bottom line. This is the purpose of factoring, is to get these solutions for x so that we can identify what those intercepts are. Okay, now let's look at one that isn't factored. Here we have this quadratic equation set equal to 0. Okay, in order to find out what x equals, we need to factor this. Okay, so we have w and w. This is a negative, so we know that we need to have a positive and a negative. Now we need the factors of 8 that give us a sum of -2. Well, 4 and 2. -4, +2. Okay, we set these equal to 0. W plus 2 equals 0. W minus 4 equals 0. Okay, now without actually writing out the algebra here, I can see that W equals -2 and +4. Okay, if you need to do this step, that is perfectly fine. Do it. Okay, but if you can go from here to here, go ahead and do that too. That's fine. All right. Okay, let's look at the next one. Here we have 25x squared minus 49. Now, if we look at this, what we have is difference of squares, right? This is squared, subtraction here in the middle. So, difference of squares, we know we take this one, square root it. We have 5x and 5x. We have plus and minus. Square root of this is 7 and 7. Okay? Now, I set each of these equal to 0. I'm going to need a little bit more space. So 5x plus 7 equals 0. 5x minus 7 equals 0. Okay? Now, what I do here, we're solving for x, so I subtract 7. Now we have 5x equals -7. Now I need to divide by 5. So here, x equals -7/5. Okay? Add 7, 5x equals 7, divide by 5, x equals 7/5. Okay, so here we have fractions, x equals -7/5, x equals 7/5. Okay? Still the same idea though. It still gives us these 2 points here. Okay? All right. Let's look at the next one. Now, first thing that I notice here is that this is written incorrectly. Okay? So, in order for this to make sense for me, I'm going to rewrite it in proper polynomial order. minus 2t minus 24. Just because that helps me. Okay, so now if I'm factoring, I have, this is a negative. This is a negative. So I know that I have to have a positive and a negative here, okay? My product is 24, so I'm thinking of factors of 24 that have a difference of 2, and I know that that's 6 and 4. Okay, so we have a negative 6 and a positive 4 equals 0. Now if I set these equal to 0, t plus 4 equals 0, t minus 6 equals 0. So t equals negative 4 and positive 6. Okay. All right. Okay, now we're getting into some more complicated stuff. Okay, let's take a look at this one here. Now, first thing that I notice here is that I can take out a greatest common factor of 2. And I'm definitely going to do that. So if I take out a greatest common factor of 2, I have 2m squared plus 13m plus 15 equals 0. Okay, I want to factor this one. So I'm factoring using the AC method, right? 15 times 2 is 30. Okay, so now I want factors of 30 that add up to 13. Now I'm thinking in my head, and I already know that 10 times 3 is 30, and that adds up to 13. So I can go 2m squared plus 10m plus 3m plus 15 equals 0. We still have this 2 out front. We're just going to leave it there for now. Okay. All right. Here we take out a greatest common factor, 2m, m plus 5 plus 3, m plus 5 equals 0. Okay, so I'm kind of running out of space a little bit. So here we have the factors. So we have the 2 here. Then we have 2m plus 3 and m plus 5. And that equals 0. Okay. Now, here you run into something that we haven't seen yet. We have actually 3 factors. Okay. Now, I have to set each of these things equal to 0. So I have to say 2 equals 0, 2m plus 3 equals 0, m plus 5 equals 0. Okay, now in this case, I can't solve anything here. I don't get an m value. Okay, so that just kind of goes away for right now. Okay, this one I solve, I subtract 3, so now I have negative 3 divided by 2, so m equals negative 3 halves. This one is negative 5. Okay. So far, so good? Okay. Let's go back over here. Ooh, look at this. Now, you might be inclined just to start this just as it is. However, all of these parts need to be on the same side of the equal sign. Okay, so we have to move, subtract the 4x, subtract the 12, so that everything's on the same side. Okay, so we'll have x squared minus 4x minus 12 equals 0. Okay, now I'm going to factor this. This is a negative, so I know that I need positive and negative. So x plus, x minus. Factors of 12 that have a difference of 4, 6 and 2, minus 6 plus 2. So now I have x plus 2 equals 0, and x minus 6 equals 0. So here x equals, whoops, negative 2 and a positive 6. Okay. All right. Let's look at this one here before we move to the last two. Now, with this one here, what we're looking at is the exact same thing we've been working with. The only difference is that this says f of x. Okay? Now, in this case, we want to find those x-intercepts. We want to find what x equals when y equals 0. So we're just going to replace this with 0 and say 0 equals x squared minus 7x plus 10. Okay, now let's factor it. Okay, we want factors of 10 that add up to negative 7. So x minus 5 x minus 2. Set these equal to 0, and x equals 5 and 2. Okay? All right. Let's go over here. Actually, let's go up here. Now, here I see that there are 4 terms. Okay? I also see that they're on different sides of the equal sign. I know that if I have 4 terms that I can factor it using grouping. However, just like I said over here, everything has to be on the same side of the equal sign. Okay? So the first thing I need to do is move everything over. Okay, so I'm going to subtract 36x and add 147x squared. And then when I do that, I'm going to write them in the proper order. So I'll have 49x cubed plus 147x squared minus 36x minus 108. Okay, now I can group. Okay, now I know that this is a common factor of 49x squared. I have x plus 3, and then negative 36x plus 3. Okay, I'm going to go over here. I have 49x squared minus 36, and I have x plus 3 equals 0. Now, if you're looking at this and you're saying, that looks a little bit familiar, you are 100% correct. This is a difference of squares. So here we have 7x plus 6, 7x minus 6, and x plus 3. All of that equals 0. Okay. Now, when I set these each equal to 0, I'm a little bit running out of space, so we're just going to kind of walk through what this looks like. I subtract 6 and divide by 7. So x equals negative 6/7. Here I add 6 and divide by 7. So it also equals 6/7. And here I just subtract 3, so negative 3. Now, what this means is we have 3 x-intercepts, okay? There is negative 6/7, there's negative 3, and there's 6/7. Okay? Now, that makes sense because this is a polynomial to the 3rd degree. So really, essentially, we have something that's kind of, that's kind of going like this. Or it could be going the other way. I'm really not sure. But it's curving 2 different times. Okay? That brings us to this last one over here. Now, here we have 2 quadratics. We are going to factor each one. Okay? So go ahead and factor these. I'm going to factor this one right here, and then I'll factor this one right here. Okay? X plus 3, x plus 4. This one's going to be x minus 6, x plus 3. Okay? Now, when I set all of these equal to 0, I get x equals negative 3, negative 4, positive 6, and negative 3 again. So these are all of my intercepts. Okay? We have negative 3 here twice. It is a factor of both of these different quadratics. So if we think about what this kind of looks like, this quadratic here has a negative 3 and a negative 4. Looks something like this. Okay. This quadratic here has a negative 3 and a positive 6. So it looks something like this. Okay, so in this case we have these 2 quadratics that are sharing one intercept, but we have 2 quadratic equations, 2 parabolas on our graph. Okay. Now, I talked quite a bit here about how these solutions are connected to intercepts, because essentially these solutions are intercepts. Okay. There's one more section here that has some items for you to practice. 1, 2, 3, 4, 5, 6, 7, and 8. solving versus factoring, we've kind of been doing this the whole way along, so we're not going to worry about that. So you can just cross that out. But go ahead and take some time to solve these 8 items that are here. Okay, I will solve them as well and give you the solutions so that you have those. But all you're doing is the same thing you've been doing. You're factoring. Once you factor, you're setting equal. You should have it set equal to 0 when you're factoring, and then you find those solutions. Those solutions are your intercepts. So in this section, when we're connecting our x-intercepts to our solutions, I want you to write your solutions here as x-intercepts, just like I did on these first 2 up here. I wrote them as x-intercepts, okay? So be mindful of that. Okay, so your exit card for today. Please write down what place Miss V got in the costume contest and the other person that placed, the other character that placed in the contest as well. Okay? Have fun. Bye.